Hello, class. Today we are going to be talking about average rate of change. Rate of change is a ratio describing how one quantity changes as another quantity changes. Slope can be used to describe it. So basically, rate of change is the same as slope. Now, the reason why we don't call it slope is because slope is only used for straight lines. Rate of change can be used for any any type of graph or any type of distance or change. So it doesn't have to be the same every time. Now, just like with slope, rate of change can have a positive when it increases over time, or it can be negative where it decreases over time. Now, linear functions have a constant rate of change. This is a point you need to make sure you have highlighted in your notes. Um, it's linear functions have a constant rate of change, which means that the values increase or decrease at the same rate over a period of time. So meaning when I'm trying to find the slope between any 2 points, no matter which points I choose, I will always get the same answer. Um, some very important things to know. Horizontal lines have a zero rate of change, and vertical lines have an undefined rate of change. So we have to remember that in order for you to have a horizontal line, your equation is going to be y is equal to a number. And in order for you to have a vertical line, you're going to have x is equal to a number. Anytime you see those equations, you should automatically know that you have your horizontal or vertical line. Now, to find average rate of change, we can either use the first formula here, which is when you're looking at equations, y2 minus y1 over x2 minus x1. And when you look at functions, remember we said that f of x is another way to say y. So we have f of x2 minus f of x1 over x2 minus x1. And it's really important. A lot of people forget that f of x2 is the same as y2. And we are going to look at a couple examples that express why we're saying it that way. Okay, so your first example. We have the function f of x is equal to 2x squared minus 3. And right here where it says from 2 to 4, that stands for or means from the x variable 2 or from the x value of 2 to the x value of 4. What is the rate of change? This is not an ordered pair. So from when x is 2 to x is 4, what is my rate of change? So the first thing you have to do is find out what f of 2 and f of 4 is. So off to the side, you can calculate. I'll plug in 2 into the formula and find that result, and then plug 4 into the formula, find that result, and I will get 29 minus 5 over 4 minus 2. And again, the way that we got 29, 4 squared is 16. 16 times 2 is 32, and 32 minus 3 is 29. And the way we got that 5, if you do 2 squared, that's 4. 4 times 2 is 8, and 8 minus 3 is equal to 5. So those became our y values because they were the answer to that problem. And then 29 minus 5 is 24. 4 minus 2 is 2. And if I break that down or simplify it, I get 12. Now, example 2. Now that's 3 to the x power minus 2. And again, it's from the x values 2 to 5. So pause the video and try to do this problem on your own, and then unpause it and see if you did it correctly. Okay, so we would get, if we take the equation f of x2 minus f of x1, which means we would do f of 5. So we would plug 5 into our function just like we did in function notation, minus f of 2. Um, and so we would figure out what that is. And f of 5 is 241, f of 2 is 7. And so 241 minus 7 over 5 minus 2, and 5 minus 2 is 3. 234 over 3, and you simplify that to 78. All right, this rate of change, again, try to pause the video try to do this problem on your own. But it's f of x equals negative 4x plus 10, and this time we're looking from negative 1 to 3. And your answer would be negative 4. Now, we have a more of a situation here. We're supposed to find the rate of change from day 1 to day 2. So if you look, we have basically an XY table right here. Days is your X values. Amount of bacteria is your F of X or your Y values. Um, so it says from day 1 to day 2. Well, my X value, when my X value is 1, what is my Y value? That's right, you guessed it. It's 19. And then when my X value is 2, what is my Y value? Right, again, it is 30. So if we were to try to find the rate of change, we are going to do 30 minus 19 over 2 minus 1, which will give us 11. Now, if we try to find the rate of change from day 2 to day 5, I want you to pause it and try to figure that out, and then unpause it and see if you got the right answer. Okay, you're back now. If you said that the answer would be 91 over 3, which would approximately give you 30.3, that would be the correct answer, or 30 and 3/10, I'm sorry. All right, one more example. This is the last example. Um, if we in 2008, about 66 million U.S. households had both landline phones and cell phones. Find the rate of change from 2008 to 2011. So, from 2008 and 2011, again, those two numbers are my X values. So I have to figure out what are the corresponding Y values for those, and then I can solve the problem. Well, for 2008, I'm sorry, hold up. You should pause the video first and then listen to the explanation. All right, for 2008, being an X value, the f of X value would be 66. And when 2011 is the X value, the f of X value is 51. So we would do 51 minus 66 over 2011 minus 2008. And when we do that math, we would get m is equal to negative 5. So what does this mean in this situation? And it decreases by 5 million households per year from 2008 to 2011. So they make the number of landline phones and cell phones in the households fell from 2008 to in 2011 by 5 million per year. All right, that is your lesson on average rate of change. Um, Thank you for your time.